Lesson 6-1, Ratios and Unit Rates. Today we are going to do two things: find rates and unit rates, and use measures expressed as rates and products to solve problems. Alright, so to begin, we're going to review really quick about what a ratio is. A ratio is a comparison of two quantities by division. You can write a ratio in three different ways. If I have the ratio 10 to 15, I say it 10 to 15, but I can write it with the word to, 10 to 15, with a colon, 10 to 15, or as a fraction, 10 over 15, 10 to 15. So one more example, if I had the ratio of 3 to 4, I could write it as a fraction, with a colon, or with the word to. So that's a ratio. Now, more specifically, a rate is when you have a ratio, so we'll use our 3 to 4 again, but it's comparing quantities in different units, meaning maybe this is 3 miles per 4 gallons. So the unit on top and bottom are different. A unit rate is a rate like this where there's two different units, but it has a denominator of 1. A unit rate that we see a lot that's very common is when we on the freeway can drive 70 miles in 1 hour. So it's a rate because the units are different, but it's a unit rate because the denominator is 1. So I'm going to show you how to change a rate to a unit rate. So this example problem they gave you, a car goes 425 miles on 12.5 gallons of gas. We want to find the unit rate, meaning we want to find something over 1. So it's really important that we know our labels first. I'm going to put miles on top and gallons on bottom. So miles over gallons. Alright, so if a car goes 425 miles in 12.5 gallons of gas, I want to set this equal to another rate, but this time only has 1 gallon on bottom. So a easy way to solve this is to look at how did we get from the bottom, how do we get from the bottom 12.5 gallons to 1 gallon? Well, if I take 12.5 and divide it by 12.5, I get 1. So let's do that same thing to the top number. 425 divided by 12.5, 425 divided by 12.5, I get 34 miles per 1 gallon. That's my unit rate. We're going to use unit rates to do some comparison. Kirsten drove her car 227 miles on 9 gallons of gas. David drove his car 335 miles on 11 gallons. Which car gets the better gas mileage? Who can go the most miles for the least amount of gallons of gas? Well, I'm going to set these two rates up the same way. Miles on top of gallons. So for Kirsten, she drove 227 miles in 9 gallons. And for David, he drove 335 miles on 11 gallons of gas. So to compare these, I need them to have the same unit on bottom. They need to be unit rates. We want to get them to 1 gallon. So if I look at Kirsten's, to get to 1 gallon from 9 gallons, I'm going to divide by 9. Do the same thing to the top. 227 divided by 9 is, and we're going to round, 25.2 repeating gallons. Alright, then looking at David's, from 11 gallons to 1, I'm going to divide by 11. And I'm going to do the same thing on top. 335 divided by 11 is 30.45 repeating. So this is really easy to tell now that they're both in the same unit rates. David can go more miles per 1 gallon. Alright, one more example, of unit rates. A 6-pack of diet soda costs $3.59. And a 12-pack of the same soda costs $5.88 at a different store. Which is the better unit rate? We want the least price now per can. So I'm going to set this up as price over can. So in my first example, a 6-pack, so I'm going to put 6 on bottom, 6 cans, I can get for $3.59. And at the other store, I can get 12 cans, 12 on bottom, for $5.88. I'm going to make these unit rates. So I want per 1 can is what I'm solving for. 6 to get to 1, I'm going to divide by 6 to the bottom and to the top. $3.59 divided by 6 is 0.60 cents if I round it. That's a money sign. And divide by 12 on this one, same thing to the top. $5.88 divided by 12 is 49 cents per can. So it's the better deal. You're paying less per can to buy the 12-pack. All right. Example number 2 is converting rates. You saw a problem like this on a challenge problem on a quiz in our last chapter. So when converting rates, you can use dimensional analysis to check your answer. Here's what that means. If a turtle swims at a rate of 10 miles per 1 hour, that's a unit rate, it's over 1, how many feet will it swim in 5 minutes? We want our answer, right now it's in miles per hour, we want our answer in feet per second. So just like last chapter, we're going to use conversion factors to get from miles to feet and hours to second. All right, now I know that in 1 mile, I'm going to put it on the bottom to cancel out my labels. In 1 mile, there are 5,280 feet. I also know that in 1 hour, since hour is on bottom down here, I'm going to put it up top. In 1 hour, there's 60 minutes in an hour and 60 seconds in 1 minute. So 1 hour is 60 minutes. I'm going to do one more conversion. In 1 minute, there are 60 seconds. That's all the multiplying I need to do. Now, if I look real quick and cancel out my labels, miles and miles cancel out. Hours and hours cancel out. Minutes and minutes cancel out. We are left with feet per second, which is what we want our answer in. So now I'm just going to multiply across. 10 times 5,280 times 1 times 1. I don't have to do anything. Oops. I get 52800 over 1 times 1 times 60 times 60. Well, 60 times 60 I know is 3,600. I'm going to do the division, and I get about 14.6 repeating feet per second. So this turtle that swims at 10 miles an hour is going 14.6 feet per second. The dimensional analysis is using conversion rates and ordering them correctly so labels or units cancel out. We had miles per hour, and miles canceled, and hours canceled, minutes canceled, so we were left with our feet per second. All right, I'm going to do one more example here just to show you how dimensional analysis works. 3.5 quarts per minute, 3.5 quarts, remember whatever they give you, write it down, per 1 minute, times, we need to get to gallons per hour. I know that there are 60 minutes in 1 hour. I put minutes on top so that the minutes cancel out. And from quarts to gallons, I know from last chapter there are 4 quarts in 1 gallon. So quarts cancels. I now multiply 3.5 times 60. I get 210. 1 times 1 times 4 is just 4. Divide 210 by 4, I get 52.5 gallons per hour. All right, last example. Some measures are expressed as products. For example, person days are a measure of the amount of time needed for a number of people to complete a job. So if a job takes 2 people working for 1 day, then it takes 2 people times 1 day, or we call them 2 person days. We're going to use this to solve a problem. A company has a job that will take 240 person days. 240 person days is our unit label to complete. How many workers are needed to complete the job in 30 days? So 240 person days, but we only have 30 days to get the job done. We want to know how many people we need. Well, if you look really quick, the way we set this up, days and days cancel out. If I take 240 divided by 30, my label is persons or people. 240 divided by 30 equals 8. The answer is 8 people to get this job done in 30 days. All right, here is where I'm going to stop. You have 4 problems to complete for tomorrow, so you can pause this and get these written down. Each answer will be in a unit rate, so 1 is your denominator. Good luck to you.